I wanted to take a minute to give some overall feedback on the induction investigation. So kind of question by question. Which position of the magnet which position of the magnet will result in the greatest induced velocity? We were all over the board here in terms of different positions, but it is not position that matters. It's motion that matters. So if you take that magnet to any of those positions and you leave that magnet at rest, you're going to get 0 voltage that is induced. So this was none of the above. Position doesn't matter. Number 2, which has the greatest impact? By and far, we were on motion of the magnet relative to the coil, and that is exactly correct, because that motion is going to cause a changing flux, and a changing flux will induce an EMF or a voltage. On the third one, consider the motion of the magnet, which results in the greatest voltage. We were all on track there. Fastest motion, highest voltage induced. Number 4, consider the magnetic flux, which results in the greatest induced flux. Key in on the change. So we were 50-50 there. It's not a high value, it's not a low value, it's how that flux is changing. The greater the d phi dt, the greater the induced voltage. 5, do an experiment, draw a conclusion. When the voltage is induced, how does the number of wraps in the coil impact the induced voltage? Pretty much we were all on track there. More wraps in the coil, higher voltage, direct relationship. Each wrap constitutes an area. And since we know that magnetic flux is a B dot A, the more area we have, the more flux we have. The more flux we have, the greater change we can have in that flux. Number 6, notice you take the signs now. Compare the signs: North Pole approaching, North Pole moving away, all on target there. Opposite signs, because the field lines, you are moving towards, you are increasing the flux. Moving away, you are decreasing the flux. Lenz's law, you are fighting that change. You will oppose the change, so you will have opposite signs there. 7, compare the signs of the induced voltage for a North Pole approaching to a South Pole approaching. Those should also have opposite signs. Okay, North Pole approaching, you're increasing the flux into the area. South Pole approaching, you're increasing the flux that's going out or towards the magnet, away from the loop. And so those are different changes, and you should have opposite signs there. Number 8, repeatedly click and change north to south. What happens? Your field lines stay in the same position, but they do change directions. So from like a positive 2 Teslas to a negative 2 Teslas, that's a big change, going from 2 to 1 to 0 to -1 to -2. And so you will get an oscillating voltage between your maximum positive and your maximum negative. Overall, summarize what has to happen for a voltage to be induced. Key in on the change. Changing magnetic flux. Okay, you can do that with changing the speed. You can do that with switching the directions. Anything that's going to affect that flux, that B dot A, change in the field, change in the direction, change in the area, is going to induce a voltage in the coil. Ponder physics.